1943, a secret test site somewhere in California. A complete forward fuselage section of a medium bomber sits on the ground, trucked in from the factory, bolted down, well away from anyone who might see it. Inside it is a field artillery piece, not a machine gun, not an autocannon. A 75mm cannon, a direct descendant of the famous French 75 of the First World War, the same basic weapon that was going into Sherman tanks. The barrel weighs 893 pounds on its own and runs more than 9 feet long. Each shell weighs nearly 15 pounds and has to be loaded into the breech by hand. Nobody knows what will happen when it fires. Nobody knows whether the muzzle blast will simply tear the nose off the aircraft. So they fire it. Then they strengthen the structure and fire it again and again, progressively reinforcing the airframe until it can take prolonged firing without breaking apart. The result was the North American B-25G Mitchell, an aircraft that carried a tank gun in its nose and was designed to sink ships by shooting holes in them at close range. To understand why anyone thought this was a reasonable idea, you have to understand the problem in the Southwest Pacific in 1942 and 1943. Japanese logistics in that theater ran on ships. Freighters, transports, barges, and small craft moved men, fuel, and ammunition through an enormous archipelago. Cutting that flow was the single most valuable thing Allied air power could do, and it was proving extremely difficult. High-altitude bombing against moving ships was close to useless. A bomb dropped from 20,000 feet at a vessel that is maneuvering has a very low probability of hitting anything. The Army Air Forces were expending enormous tonnages of ordnance for very few sinkings. The answer developed in theater, largely under 5th Air Force and driven by Major Paul Pappy Gunn, was to go the other way entirely. Come in at wave-top height, attack from a few dozen feet above the water. 2 low-level tactics were refined with help from the RAF and the Royal Australian Air Force. Skip bombing, in which a bomb is released so that it bounces across the surface into the ship's hull, and mast-height bombing, delivered from an altitude roughly level with the target's masts. Both required flying straight at a defended warship at minimal altitude. Both worked, and both raised an obvious question. If the aircraft is already going to be pointing directly at the ship from close range, why not give it something that can punch through a hull? The answer, in the most literal sense available, was a tank gun. Now, before we get to how this actually performed in combat, if you are enjoying this deep dive into aviation history, hit subscribe. It takes a second, costs nothing, and helps this channel keep making these. The B-25G was designated NA-96 by North American. A standard Army M4 75mm cannon was mounted to fire forward through the nose. The concept had already been shown to be feasible through experiments on a converted Douglas B-18A Bolo, but the effects of muzzle blast on the Mitchell's nose structure were entirely unknown, hence the trucked-out fuselage section and the secret firing tests. The aircraft that emerged was heavily reworked. The bombardier's position was gone, so the pilot fired the nose armament and released the bombs himself. The co-pilot position was eliminated to make room for the gun system. The crew was 5: pilot, navigator, who doubled as cannoneer, upper turret gunner, radio operator, who also worked the ventral turret when fitted, and 1 more. Armor was added forward of the instrument panel, forward of the loader's station, around the 75mm ammunition rack, and below the windshield, with an external flak plate below the cockpit on the left side. Standard storage was 21 rounds of 75mm ammunition. Aiming was ingenious and entirely manual. The pilot used the twin 50 caliber machine guns in the nose as a sighting device, walking a burst of tracer onto the target and then firing the cannon along the same line. Accuracy was considered acceptable and notably better than the unguided rockets that were the alternative heavy option of the period. That sighting method deserves a moment of attention because it captures the whole character of the aircraft. There was no computing gun sight, no radar ranging, no stabilization of any kind. There was a man flying a twin-engine bomber a few dozen feet above the ocean, squeezing off machine gun rounds to see where they landed, adjusting the entire aircraft until the tracers were going where he wanted, and then firing a field artillery piece bolted into the nose. Everything about the system depended on the pilot's hands and eyes, and on an airframe steady enough to hold a line. The first B-25Gs arrived in the Southwest Pacific at Brisbane in July 1943. 400 were built new, and 63 B-25Cs were converted to the G standard. In combat, the cannon did real work. During the New Britain campaign, B-25Gs expended 1,253 rounds of 75mm ammunition in 36 days against flak positions, shipping, and other targets. The gun could engage vessels from up to around 2 miles away. Against barges, freighters, and small craft, it was genuinely effective, and a single hit could sink a smaller vessel outright while doing significant damage to larger ones. Aircraft arriving in theater expended all their 75mm ammunition within about 7 weeks. The concept was considered promising enough that it was carried into the next variant, the B-25H, which used a lighter T-13E1 aircraft cannon and paired it with a formidable battery of forward-firing .50 caliber machine guns. 1,000 B-25Hs were built. More than 1,000 aircraft in total were ordered with the cannon installation. And then, the whole idea quietly collapsed. The problems were not with the concept in theory. They were with the mechanics of using it in a fight. The cannon was hand-loaded. The navigator, working in a cramped space inside an aircraft pitching and rolling at low altitude over water, had to physically lift and load 15-pound shells one at a time. That produced a rate of fire measured in a handful of rounds per attack run. In practice, a crew might get 3 or 4 shots at a target. Worse, the slow rate of fire dictated the tactics. To use the gun, the bomber had to hold a steady course pointed at the target while the loader worked and the pilot aimed. Holding steady, straight, and level at low altitude in front of a warship that is firing back is the most dangerous thing an aircraft can do. The weapon that was supposed to increase lethality was forcing the aircraft into the most vulnerable possible attack profile. The gun was also punishing to the airframe and the crew. Firing it popped rivets. It filled the cockpit with smoke and cordite. The muzzle blast assaulted the ears of everyone aboard. The recoil stressed a structure that had needed progressive reinforcement just to tolerate it in testing. Then, there was the arithmetic of what else could occupy the same space and weight. Strafing with heavy machine guns had proven devastatingly effective, particularly after the Battle of the Bismarck Sea. Later, B-25 gunships carried batteries of 8 or more forward-firing .50 caliber guns, and the final and most produced variant, the B-25J, could be configured as a solid-nose strafer, carrying up to 18 .50 calibers in total across nose, cheek blisters, turret, waist, and tail. That configuration could put thousands of rounds per minute into a target over a 5-second burst. An account from a 345th Bomb Group attack in April 1945 describes a run at 30 feet in which 10 Browning M2 machine guns fired simultaneously at 7,500 rounds per minute, delivering more than 1,000 heavy rounds in a continuous 5-second burst as the target maneuvered. Compared with 3 or 4 hand-loaded cannon shells, the choice was not close. By early 1944, the situation had shifted decisively. Floating targets were becoming scarce as Japanese shipping was destroyed or withdrawn. Units in the field began stripping the 75mm cannon out of their aircraft and replacing it with more machine guns. Some crews trained on the cannon-armed variants in the United States arrived in the Pacific to find their squadrons had already removed the guns. The cannon-armed Mitchells were used exclusively in the Southwest Pacific and in the China-Burma-India theater. Some B-25Hs went to the Navy and Marine Corps as PBJ-1-1H aircraft, some with wingtip radar. The B-25 was not alone in this experiment. which is worth remembering before judging it too harshly. Several nations tried mounting heavy cannon in aircraft during the same period. The British fitted a 57mm gun to the Mosquito FB Mk-18 for anti-submarine and anti-shipping work. Germany went further, putting 75mm Pak-40 anti-tank guns into both the Henschel HS-129B3 and the Junkers Ju 88P1. Every one of these aircraft shared the same fundamental characteristics: a heavy weapon, a low rate of fire, significant recoil, and a requirement to fly straight at the target. And every one of them ended up as a fascinating dead end. That convergence suggests the problem was structural rather than national. Multiple independent design teams, working under different air forces with different doctrines, reached the same conclusion at roughly the same time, by roughly the same route. They all wanted more destructive power per hit. They all discovered that the aircraft could not afford the time the weapon required. They were not a disaster. They were a practical attack aircraft that carried a weapon nobody needed. The verdict from those who have studied the program is fairly consistent. The failure was not that the idea could not be made to work, but that it was not the most efficient solution to the problem it was aimed at. Cannons are efficient when you have time to sustain fire. A combat pilot on an attack run has seconds. In those seconds, volume beats caliber, which makes one detail worth noting: the idea itself never entirely died. The United States Air Force today operates AC-130 gunships, mounting 105mm howitzers, larger than anything the B-25G ever carried, and they work extremely well, because those aircraft loiter in slow circles above a target and have all the time in the world. The B-25G's cannon failed not because a big gun on an aircraft is absurd, but because the tactical situation gave it no time to be useful. 1943, a bolted-down fuselage section in a secret corner of California, and engineers firing a tank gun through the nose of a bomber to find out whether the airplane will survive it. They made it survive. They armored it, reinforced it, put it into production, sent 400 of them across the Pacific, and gave them to crews who flew them at wave-top height into the guns of Japanese destroyers. And what those crews learned, in the space of a few months, was that they would rather have had more machine guns. That is not a story about a bad idea. It is a story about the difference between a weapon that works on a test range and a weapon that works in the 6 seconds a pilot actually has.